Hi everyone. So today I'll be going through practice exercise 10.2 and it's called angles at the circumference. Okay, so we'll start off with question 6. So question 6, very nice, right? Diagram is given. So AC is a diameter of a circle, right? So AC is the diameter over here, and then circle center O, right? So the chord CD, right? So CD is over here. The chord is parallel to BO or OB lah. So this is actually like the radius of a circle, right? Then they say that angle BAO, so this angle over here is x plus 6. And then angle DCO, this is 3x minus 2. So find the values of x. So as you can see, because they tell us, right, that CD is parallel to BO, correct? So that means I can say that this is, okay, so parallel, right? So angle BOC, right? So angle BOC is actually equals to angle OCD, right? Which is 3x minus 2 degrees. Why? Because alternate angle. Okay, so alternate angle CD parallel to BO. Okay, so this part over here, this angle is 3x minus 2 degrees. All right, so how does it relate, right? How do we, what is the purpose of finding this angle, right? How do we find the value of x? So in this case, we must form an equation. All right, as we have learned in exercise 10.2, right? We can say that angle BOC is equals to 2 times of angle B, sorry, B AC, right? Because why? Angle at center, right? Angle at center equals to 2 times angle at circumference. Okay, so this is what we have learned in exercise 10.2. All right, so that means we can say, so with this property of circles, we can say that 3x minus 2 is equals to 2 times of x plus 6. Okay, angle at center equals to 2 times angle at circumference. All right, so 3x minus 2 equals to 2x plus 12. Right, so x is equals to 14. Okay, yeah, so this is it for question 6. Okay, let's take a look at question 10. So in the diagram, A, B, C, and D are points on the circle. So A, B, C, and D points on the circle, right? And then center O. So AOB is the diameter, right? Diameter, and OC is parallel to AD. And angle OCB is 65. So find the value of X. So the first thing we start. So, right, X is over here. Okay, so if you think about it, we can say that since angle OCB is 65, that means angle OBC over here is also 65 degrees. Why? Because OC is the radius, right? So OB also must be the radius. So triangle OCB is actually an isosceles triangle, right? So we can start by writing OBC, right? Is equals to 65 degrees. Okay, we can write. Should write this way now. Angle OBC equals to angle OCB equals to 65 degrees. So base angle of isosceles triangle. Okay, so that means we can find out what is angle BOC lah. So angle BOC, right, is equals to 180 degrees minus 65 minus 65. All right, so that will be 50 degrees. Okay, so this is 50 degrees. Right, so x, right, degrees is actually equals to 50 degrees divided by 2 equals to 25 degrees. How come? Angle at center equals to 2 times angle, right, at circumference. Okay, because angle, right, angle BOC, right, is the angle at center. Okay, and then angle OAC, which is x, is actually the angle at circumference. All right, so x degrees times 2 lah. Yeah, so in order to find x is just 50, right, divide by 2. Okay, so let's move on to part B. So part B over here, right? So part B, this angle y degrees is actually related to this. So how are they related? Angles in the opposite segment. So that means these two angles will add up to 180 degrees. So that means I can say that y plus 65 degrees is equals to 180 degrees. Right, so y is equals to 180 minus 65, so equals to 115 degrees. So the reasoning here is uh, angles in the opposite segment and they add up to 180 degrees lah. Okay, can. So this is for part B. Let's move on to part C, right, to find Z. So Z over here, right, is actually equals to this angle over here, this one. Okay, so we can see that Z degrees, right, is equals to angle ACO. Sorry, ACO. How come? What is the reason? Because it's alternate angle, right? Alternate angle, AD parallel to OC, right? AD parallel to OC. So you form, there's a Z over here, right? So this is actually Z degrees. And you also can tell that actually Z degrees is also the same as X degree. How come? Because OA and OC are radius of the circle, right? So that means they are both uh, same angle lah, because it's an isosceles triangle. So that means I can say that Z degrees is equals to X degrees, right? Which is 25 degrees as well, because base angle of an isosceles triangle. All right. So to sum up lah, so X is 25 degrees for part A, B, Y is 115 degrees, and part C, Z is 25 degrees. Okay, and that's it for question 10. Let's take a look at the last question, question 11, that I'm going through for exercise 10.2. So O is the center of the circle, right? AOC is the diameter over here, right? AOC is the diameter, and OB is parallel to DC, right? Parallel. So AC and BD, right, intersect at E. Okay, and angle OBD is 23 degrees. So part A, find angle ADB. So where's ADB? ADB over here lah. Okay, so let's label. So this is the angle that we want to find. Okay, great. So at the start, so we can say that angle O, part A, so angle OBE, right, is equals to angle EDC, which is 23 degrees. EDC is over here, lah, right? So this is 23. How come? Because alternate angle, all right? Alternate angle, comma, OB, sorry, OB parallel to DC. Okay, so this is 23. And because AOC, next part, AOC is the diameter, right? So that means we know that angle ADC, right, is equals to 90 degrees. How come? Because right angle in a semicircle. In a semicircle, AOC is diameter. All right. So this entire thing is 90. So how to find angle ADB? So angle ADB, very simple. It's just 90 degrees minus 23 degrees, and that will give me 67 degrees. All right. So angle ADB is 67 degrees. All right. So let's move on to the next part, part B. Okay lah, right here lah. So AOB. So AOB is over here lah. So just one angle property. So I can say that angle AOB is 2 times of angle ADB. How come? Because angle at center equals to 2 times angle at circumference. Okay, so angle AOB, right, is equals to 67 degrees times 2 lah, which is 134 degrees. Okay, yeah, so this is 134 degrees. Okay, so now we need to find AED. Where's AED? This angle over here. Let's label pink color. AED, this angle over here. Okay, so basically since I have AOB, right? Let's find out what is EOB. Right, so let's see, angle EOB, right, equals to 180 degrees minus 134 degrees, which is 46 degrees, right? So this is adjacent angle on a straight line. Adjacent angle on a straight line. All right. Okay, so we know that EOB is 46, and then we know that OBE is 23, so we can actually find out angle AED. So angle AED equals to 46 degrees plus 23 degrees equals to 69 degrees. Okay, the angle property here is external angle of a triangle. All right, so it is 69 degrees. Okay, last part C. Let's use blue. Part D, sorry. Let's use blue. So angle ACD. ACD is over here. All right, this angle over here. Okay, so how do we find out the angle? So basically, we just got to find out what is angle DEC lah. So angle DEC equals to 180 degrees minus 69 degrees equals to 111 degrees. Right, so angle property, adjacent angle again on a straight line. Okay, so this DEC over here is 111. So how to find out angle ACD is to take 180 minus 111 degrees minus 23 degrees. The angle EDC over here lah. So equals the 180 minus 111 minus 23. 23. So it's 46 degrees. Okay, so the angle property here is sum of angles in a triangle. All right. Okay, so yes, this is the last question for the exercise 10.2. So question 11.